Welcome to the Math Record. This video will cover the second part of the ICTM Regional 2020 Division AA Freshman Sophomore 8-person, which I'll be covering questions 15 and 17. Let's begin with 15. Circle O and C has equation x squared plus y squared equals 100 and x minus 20 squared plus y squared equals 400 respectively. Their common external tangents are legs of isosceles trapezoid. Determine the perimeter of this trapezoid. Okay, so we have to graph these circles and then make a trapezoid. So the first circle is at the origin. Square root of 100 is 10, so its radius 10. So something like that. And then we have another one that's at center 20, 0, and it has square root of 400 is 20, so it goes through the origin. So it's a bigger circle, goes through the origin. So something like that. Okay, now let's label some of our lengths. So we know this is radius 10, so from here to here is 10. Then make a center of the bigger circle right here. So we know it's radius 20, so 20 minus this 10 makes this length of 10. Now let's make our trapezoid. So we need to make our common external tangents. So we have one like right here. So, okay. So we have one here and we have another one right here. So overestimating it. Okay, cool. Now we need to make a point of tangency, which is basically right here, right here, right here, right here. And then we have to make our lines to connect these 2 points and then connect these two, which makes our trapezoid. Okay, so how do we, so first thing we need to do to get to find the length of our common external tangent is basically we need to connect the center of the circle to that point. So let's just center of the circle to points of tangency, center of the circle to point of tangency. And then we're gonna make a line that's parallel to our external tangent. So something like this, and then we're gonna connect it to this line right here. So basically what we did is that this is a line of tangency, so it's 90 degrees to the circle, and this is 90 degrees. And since we made this line is parallel to this line, because that's what we made it as, then this is 90 degrees, and this is also 90 degrees. So basically we made a right triangle right here. So if we call this our external tangent E, this length is 10 because that's a radius, and this is length is 10 because it's a rectangle. So this length would be our radius, which is 20. 20 minus 10 is 10. So now we use the Pythagorean theorem for this. So 10 plus 10 is 20. So 20 squared equals 10 squared plus E squared. So that's 400 minus 100, which is 300. Square root 300 is 10 square root 3. So that's our length of our external tangent. Okay, so let's label that again. Then 10, 10, 10 square root 3, 10 square root 3, and 10 square root 3. And now how do we get the length of these lengths right here of our base of our trapezoid? Well, basically, what I notice is that I see a square root 3. And usually for square root 3, the opposite is going to be a 60 degrees. And how I know is that the 30, 60, 90 triangle, opposite of the 30 is a half of the hypotenuse, and opposite of the 60 is square root 3 times divided by 2 of the hypotenuse. So opposite of the square root 3 is going to be 60, because that's what it's usually for the special right triangle. So this is going to be 60 degrees. So let's check if that's true. 10 plus 10 is 20. 20 times square root 3, which is 20 square root 3, and then divide by 2, which is 10 square root 3, which is right, which is this. So this is 60 degrees. So if this is 60 degrees, then this is 30 degrees. And we know that this is also a triangle. So basically this would be 30 degrees. So this is a 180 degrees because that's a line. So basically 180 minus the 90 minus the 30, that means this is 60 degrees also. So this is also 30. So we're working with a bunch of 30, 69 triangles. This is also 90 degrees. And how I know is that because we made two circles that are symmetrical to the x-axis, so these will make a isosceles trapezoid. So opposite of the 60, as I said before, is half and then multiplied by square root 3 of our hypotenuse. So 10 and 10, that's 20. So 20 times square root 3 is 20 square root 3, divided by 2 is 10 square root 3. So this length over here is 10 square root 3. So we need to find the entire length, which is twice that. So 10 square root 3 times 2 is 20 square root 3. Now we need to find this length. So basically, this hypotenuse, which we use this triangle, We have our hypotenuse here is length 10 because that's our radius. Opposite of the 60 is 10 squared 3. So 10 squared 3 divided by 2, so 5 squared 3. So that's half of it. Now multiply by 2, so that's 10 squared 3. So now we get everything. So this base is 10 squared 3, this base is 20 squared 3, and our external tangents are 10 squared 3. So 10 squared 3 plus 10 squared 3 plus 10 squared 3 plus 20 squared 3, 10, 20, 30, 50. So that's 50 squared 3 as our perimeter for number 15. Okay, now next one, number 17. The line kx plus 4y minus 16 equals 0 is tangent to the circle x squared plus 8x plus 4y minus 4 y squared minus 4y plus 4 equals 0. Determine the value of k. So basically, we have a circle. So let's kind of graph this to see what's happening. So now let's actually see what this, because we need to find the center of the circle. So half of 8 is 4, so this is x plus 4 squared. And then half of negative 4 is negative 2, so this is minus 2 squared. So 4 squared, which is 16, 2 squared is 4. So 16 plus 4 is 20. So we have a plus 20 here on this side, but on this equation we have a plus 4. So we have to take away 16 equals 0. So that means it's equal to 0. I mean equal to 16 on the other side. So basically, we know that this is got to be radius 4 because that's 16. So that's 4 squared. So that means our center is at negative 4, 2. So negative 4, 2. And it has a radius of 4. So it's some kind of circle like this. So we know what that looks like. So let's delete it and I'll make a better circle so we could visualize it better. Okay, so something like that. And this is 4. And this is negative 4, 2. So that basically tells us that since it's radius 4, right, that means it touched the y-axis at 0, 2. And now we need to find the k value for our line of tangency, which is basically, first we need to find a point that's in that line. And it's pretty simple. Let's say x equals 0. So k times 0 is 0. That means y has to equal 4 because 4 times 4 is 16 minus 16 equals 0. So we know that a point in this line is 0, 4. So let's say it's right here, right? Because it's like twice the distance of our point for point right here. So that's 0, 4. And it's in that line. So basically how our line is going to look like is that from this point to our circle. Okay. And then our point at tangency is right here. So what we could do to find the length of, there's numerous ways you could use algebra, geometry, whatever to find the length of, the equation of this circle. But what I like to use generally, because it's two lines, is that I kind of like to use vectors all the time. So I'm going to make a line that connects these two, and I'm going to extend this line outward. Okay. So basically, what I know this equation, that equation, if we put it in point intercept form, right, this would just be negative k divided by 4x, and then negative 16 divided by negative 4 is plus 4. So that's just equal to our y, because that's our equation. So I just set it to equal to y instead of this form, the standard form. So equal to y. Now we need to find the equation of this line. Well, 4 minus 2 is 2. 0 minus negative 4 is 4. So 2 divided by 4 is 1 half. So this slope is 1 half x. And it goes through the y-intercept 4, so plus 4. So we have the equation of this line. So what do we do with this line? Well, basically, what is the vector of this line? Well, it's pretty simple. It's just the vector is the change in x and then the change in y. So the change in x, as you see on the bottom for this slope, is 2. And the change in y is 1. So what's the vector of this line? Well, if you look at here, what's the change in x? Well, that's 4. What's your change in y? Negative k. Okay, it doesn't matter if this is negative 4, then this could be k, but I just chose 4 because you could go 4 and then go negative k. So it just seems a little bit more precise. So it makes sense of what's happening. So now what we could do is that um, what I'm going to use is cosine of theta is equal to the dot product of our two vectors, which we could call a and b, divided by the magnitude of a times the magnitude of b. And this is a formula that's really, really useful, which might not be taught in algebra or geometry because it's usually in pre-calculus or calculus, but it's a really, really cool formula. So we need to find the angle between our two vectors. So basically, it's pretty simple. All we need to do is we get our line from this point, and we could go it, and we can make it to the origin of our circle. So this line, if it goes from the point of tangency, because there's a line of tangency, then this is 90 degrees and we just made a right triangle. So all we had to do is that when you find this length, which is pretty simple, because 0, 4, 0, 2, that's a distance of 2. So this has to be a distance of 2 because that's a common external tangent of what we did in like number 15. It's the same idea. So, well, it's not a common external tangent, but it's a tangent. So it has to be the same length because it stems from the same point. Now, how do we get this length? Well, that's the radius. So what's the radius of our circle? Well, it was 4, because when we get our equation, it was like x plus 4 squared plus y minus 2 squared equals 4 squared, because it's equal to 16. 16, so this would be radius 4. So basically, what is the hypotenuse? Well, 4 squared is 16, 2 squared is 4, so 16 plus 4 is 20. So this is square root 20 as our hypotenuse. So so our angle with theta is the same angle here as theta. So basically, if we use our formula, cosine of theta is equal to a times b, I mean the dot product of a and b, divided by the magnitude of a times the magnitude of b. So cosine of theta, our theta is cosine of that is 2 over square root 20 is equal to the dot product of A and B. And it's pretty simple. It's just 4 times 2, which is 8. And then negative k times 1, so that's negative k. So that's minus k. And you add those together, basically. So it's 8 and negative k, add them together is 8 minus k. And then magnitude of A, so that's just 2 squared plus 1 squared, and then square root of that. So that's 2 squared, which is 4, 1 squared is 1, so that's plus 4 plus 1 is 5, so that's square root 5. And then square root of b. So 4 squared is 16. Negative k squared is k squared. So 14 plus k squared is, 16 plus k squared is 16 plus k squared. So times square root of 16 plus k squared. Okay, so now we have this formula. So what do we do now? Well, basically, what do we know square root 20 is? Well, that is just 4 times 5. So that is just 2 square root 5. So cancel out the 2's here. And then I see the square root 5, so cancel those out here. So basically, this side is just equal to 1. So 1 is equal to 8 minus k divided by the square root of 16 plus k squared. And then we could just move it to the other side. So that's just 16 square root 16 plus k squared equals 8 minus k. And I'm just going to move this up because I need room to do some math. And we basically don't need the rest of the other things anymore anyways. So let's delete that. And now we could square both sides. So the 16 plus k squared is equal to 16 minus, 64 minus 16k plus k squared. So I just square both sides. So then I see both k squares on here, so let's cancel that out. Move the negative k squared on this side, so that's positive 16k. And 64 minus 16 is 48. So then divide by 16, so 64 divided by 16 is 3. So we find that our k value is 3, and that's for number 17. Well, thanks for watching, and I'll see you at the next math record.